Let's look at the energy required to move through our heating curve. We have different segments. So our segment 1 is where we're adding energy to the solid to bring it up to the melting point. So we're warming the ice up. In segment 2, we are converting the solid into a liquid. In segment 3, we are heating the liquid up until we reach the boiling point. So for water, that means that we would heat it from 0 degrees Celsius up to 100 degrees Celsius. And in that section, we are a liquid. In step 1, we are a solid. 2, we're transitioning between the solid and the liquid. Step 4, we're transitioning between the liquid and the gas. We're adding energy to change it from the liquid into the gas phase. And then step 5, we are heating that gas further. So we are in the gas phase and continuing to heat it. So let's look at the amount of energy it takes for 1 mole of water to heat it from negative 25 degrees Celsius up to 125 degrees Celsius. And we'll look at the calculations that we need to do for each step of this heating curve. So for segment 1, we're going to heat 1 mole of ice from negative 25 degrees Celsius to the melting point. So in this case, our melting point is 0 degrees Celsius because we're talking about water. Because we are in a region that the temperature is increasing, we're going to use our mass times specific heat times change in temperature. So if we want to find the mass, we have 1 mole of water. We know that 1 mole of water is 2 times the mass of hydrogen plus the mass of oxygen, 18.02 grams. Let's go with 18 because of sig figs, because we have 1.00 moles. So it's going to be 18 grams of water because we're dealing with our mass that we need. So our heat is going to be 18 grams times our specific heat of ice, 2.09 joules per gram degree Celsius. Our final temperature is going to be 0 degrees Celsius, our melting point, minus our initial temperature, which is negative 25 degrees Celsius. So our heat is equal to 941 joules. Now, in order to compare all of these segments in the end, we're going to do a quick conversion, convert it to kilojoules. It's 1,000 joules in 1 kilojoule. So for this particular segment, the one where we're heating the ice up, we have to add 0.941 kilojoules of energy. In segment 2, we are now converting the solid ice into liquid water. We are in the flat portion of the curve. When we're in the flat portion of the curve, we're taking moles times our heat. In this case is fusion. And so Q is going to be 1 mole times our heat of fusion, 6.02 kilojoules per mole. Our moles will cancel. And so the amount of heat that we need to add, 6.02 kilojoules to turn the ice into water. Segment 3, we are heating the water from freezing point up until the boiling point. So again, our temperature is increasing And so we're going to use the mass times the specific heat times the change in temperature. So our mass, because we're dealing with 1 mole, is the same as we calculated in segment 1, 18 grams. Our specific heat is 4.18 joules per gram degrees Celsius. And our change in temperature, our final temperature is 100 degrees Celsius. Our initial temperature is 0 degrees Celsius. And so our heat, 7.52 times 10 to the third joules. And again, so that we're looking at the same units all the way across our problem, we're going to convert this quickly into kilojoules. So 7.52 kilojoules of energy to heat water from its freezing point to its boiling point for 1 mole. Step 4, now we are boiling the water. We're converting it from liquid water into the gas. So because we're in a flat portion of our curve, we're going to take the number of moles times our heat of vaporization in this case, because we're going from liquid to gas. So our moles, 1 mole, we multiply by our heat of vaporization, which is 40.7 kilojoules per mole. And so to convert it from the liquid to the gas, it takes 40.7 kilojoules. Step 5. Now we are heating our steam, so our vapor, from 100 degrees Celsius up to 125 degrees Celsius. We are changing our temperature again, so we're using the mass times specific heat times change in temperature. So our mass, we're still looking at that same 1 mole of water, so 18 grams times the specific heat of our steam, joules per gram degrees Celsius. And our temperature is going from 125 is our final temperature. And we're subtracting 100, which was our initial temperature from the previous step. And we end up with 904 joules. Again, we'll quickly convert it to kilojoules so that we can compare our numbers. Okay, so to find the amount of heat that it takes to go from -25 to 125 degrees Celsius for our water, we need to add each of those segments. So segment 1, we had 0.941 kilojoules. So that was heating our ice up to the freezing point or the melting point. Segment 2, that was converting it into the liquid. Segment 3, we were heating the liquid up to the boiling point. Segment 4, we were changing it, we were boiling it, so changing it from the liquid to the gas. And segment 5, we were continuing to heat that gas to our 125 degrees Celsius. So if we want to find the total amount of energy, we add up all of these segments and we see that it is 56.1 kilojoules of heat that you need to add to move water from -25 degrees Celsius to 125 degrees Celsius.